students, greetings to all. In this module, we will be discussing our ongoing chapter, that is chapter 1 of chemistry, matter in our surroundings. In the earlier modules, we had discussed about the interconversion of states of matter, and we talked about the properties of various states of matter, that is solid, liquid and gases. In today's module, we will be discussing about what is meant by latent heat. Now, when I use the term that is latent heat, it actually refers to the hidden heat energy. Now, latent heat of fusion is defined as the amount of heat energy that is required to convert 1 kilogram of solid into liquid at its boiling point at 1 atmospheric pressure. So, it is the hidden heat energy, and will not see a rise in temperature at the boiling point or the melting point when ice is getting converted into water or water is getting converted into vapor. This is because the heat energy is being utilized to overcome the force of attraction or interparticle force of attraction between the molecules so that they can be converted into other state. So, when we talk about latent heat, so that is the hidden heat energy and that is utilized to break the intermolecular force of attraction between the particles, and therefore we do not see a rise in temperature. Now, latent heat can be defined as the latent heat of fusion, that is melting, or it can be referred to as the latent heat of vaporization. So, as I said, for fusion, the latent heat of fusion is the amount of heat energy required to convert 1 kilogram of solid into liquid at its melting point at 1 atmospheric pressure. Similarly, latent heat of vaporization is the amount of heat energy required to convert 1 kilogram of liquid into gas, that is vapors, at 1 atmospheric pressure at its boiling point, that is BP. I have written it over here as BP, and this will be the melting point, therefore I have written it as MP. Now, when we talk about the conversion of states of matter, solid can get converted into gas, or gas can again get converted into solid without going into the liquid state. So that is what is referred to as sublimation. Now, what do we understand by the term sublimation? So sublimation, it refers to the change of solid into gas directly without going into the liquid state. So if a substance which is solid in nature directly gets converted into vapor or its gaseous forms, skipping the liquid state, that is what is known as sublimation. Now, few examples of sublimable substances are ammonium chloride, that is NH4Cl. We are having camphor that we use for doing prayers and all, so that is camphor. Naphthalene balls or moth balls, which are used for the protection of the cloth against moth, they are also sublimable in nature. Solid carbon dioxide, that is dry ice, is also sublimable in nature. Other example is iodine. Iodine is also, that is a halogen, and it is also sublimable in nature. So when we talk about the examples of sublimable substances, ammonium chloride, camphor, naphthalene balls, solid carbon dioxide, that is dry ice, and iodine are few examples of sublimable substances. Now, when we talk about solid carbon dioxide, there is dry ice. So, carbon dioxide, we know that it is a gas which is present in the atmosphere, the composition being 0.03%. Now, this gas can be converted into liquid. It can be liquefied and then solidified by application of pressure. So, when we increase the pressure and decrease the temperature, that means we bring about cooling and we'll increase the pressure. So, the gas molecules, the intermolecular force of attraction can be increased, the distance can be reduced, and the gas can be converted into solid CO2, that is dry ice. Now, so we'll try to understand this process of sublimation with the help of an activity. So we'll discuss this with the help of an activity. For the activity, we'll require a Bunsen burner, we'll require a sublimable substance like ammonium chloride. So firstly, for this activity of sublimation, we are going to take a petri dish. So I have taken a petri dish. I have placed a wire gauze so as to prevent direct heating and to facilitate the process of indirect heating. I am going to place the petri dish on a tripod stand, as can be seen over here. There is a Bunsen burner flame which is lit up so as to carry out the process of heating or facilitate the process of heating. On this china dish, I am going to place an inverted funnel, as can be seen over here. So this is an inverted funnel which is placed on the china dish and it is plugged with cotton. So this, what I see over here, is the cotton which is plugged so that the vapors cannot escape. This, what I have placed in the inverted manner, that's the inverted funnel. This is the china dish having a sublimable substance, like for example, the substance which we have taken over here, that is ammonium chloride, that is NH4Cl. We have placed the china dish on a tripod stand. This is the Bunsen burner flame which we are using for the process of heating, and this is the wire gauze. Now let us try to understand the activity. In the china dish, we'll take a sublimable substance like for example ammonium chloride. We'll place the china dish on a tripod stand with a wire gauze so as to prevent direct heating. We'll lit the Bunsen burner flame and we'll see that ammonium chloride, because it is sublimable in nature, it will start getting converted into vapors. We have placed an inverted funnel and we have plugged it with cotton so that the vapors of ammonium chloride do not escape. As the vapors will move up, there is no space for it to escape, and therefore the vapors, they'll get deposited, they'll form deposits on the side walls of the inverted funnel. So we can see that the vapors are being formed of ammonium chloride, but then there is no space for them to escape. So therefore they get deposited on the side walls of the inverted funnel. Now this activity, it proves that ammonium chloride is sublimable in nature, and this solid directly gets converted into the gaseous form without moving into the liquid state. In this module, we had carried out discussion on the latent heat of fusion and vaporization, and we also discussed the activity so as to explain the concept of sublimation. Thank you.